volunteer to read the problem for us, please? Okay, Connor.
The school store sells pens at $2 and a notebook for $3. The equation 2x plus 3y equals 60. Describes the number of pens X and the notebooks Y that you can buy for $60.
Okay, thank you. So now we are supposed to make it, we're supposed to graph it and then find its intercepts. Well, we're going to kind of rearrange those directions. We're not going to make a table like they did in example 2 and then graph it. We're going to use the intercepts to help us graph it just like we did yesterday. So if we're going to graph this, we need to really know what is the X representing and what is the Y representing. So in this situation, what is the X representing? What about the pens? Are there colored? How many there are, right? How many are bought? Okay, and what's the Y representing? Number of notebooks. Okay, let's just go label our axes right now then, okay? So we just said that the X is the pens bought. And we don't have to put a number because, of course, the graph numbers, so we can just put pens bought. And Y was the notebooks. Okay, so notebooks bought. Now, it does not appear I've done anything on this to provide for you the grid. Okay, what did I provide for you? What part of the coordinate plane did I provide for you? The positive. What quadrant is that? No, it's actually the first quadrant. The quadrants start in the upper right-hand corner where both the X's and the Y's are positive, and it works its way around. 2, 3, and 4. Okay, so this is just quadrant 1. Okay, and we'll discuss that more in a little bit why it's just quadrant 1. Okay, we're going to use the intercepts to help us graph. So before we even decide on scales for our axes, we need to know how far out do we need to go on the x-axis and how far up do we need to go on the y. Tell me something about this equation. It's linear and it's in standard form. Standard form is efficient for what? Finding the intercepts. So to find the x-intercept, what do? Put 0 in for y. And to find the y-intercept, what do? Put 0 in for x. Okay, so go ahead and find those intercepts. And would you please also write their ordered pair names behind the intercepts, where they would be located on the graph, in other words? So the x-intercept is ordered pair what? 30, 0. The y-intercept is
0, 20.
0, 20. Okay. So that means we need to be able to go out as far as 30 on the x-axis. We need to be able to go up as far as 20 on the y-axis. So let's make a good decision that says, you know what, we've got this whole grid to use. Let's not just use one little corner, nor do we want to get off of it, so we have to draw more grid lines. So count out for me how many grid lines are there on the x-axis and how many grid lines do we have to work with on the y-axis? 20 for which? Both? Both of them are 20? Okay. So can we go by ones on the x-axis? No. Do we need to jump to 5?
No.
No, because if we go by 2s, 2 times what is 30? 15. We have plenty. So let's go by 2s on that one. So in other words, I want you to be able to start also making a good decision about what could a scale be if you have to pick it. Now, you don't probably want to have to number every one of them. So do it somehow that will show that it's going by 2s, but yet maybe you don't want to have to label every grid line. I have some students who are thinking that we label spaces between grid lines. No, we label the grid lines themselves. They're like tick marks on a number line. Because now once we have that, then we can graph our x-intercept of 30, 0. Okay, we need our y-intercept to go up to 20. So if you told me there's 20 grid lines, can we go by ones? Yeah, absolutely. Let's go by ones on the y-axis. Whether you start at 1 and go every other and do the odd numbers, or you start at 2 and go the evens, whatever way, but make sure that it makes sense. And then we're ready to plot our y-intercept, which is 0, 20. But now we need to think about the domain and the range. Before we even draw this line, let's think about the domain and the range. Okay, what would the domain be? Are there any restrictions to the domain? Can't be negative. We can't buy a negative number of pens. Okay, can we buy no pens? Yes. It didn't say that they wanted to buy some of each. It just said this is the deal. $60 is how much each of them are. Okay. So what was the domain? So we decided maybe 0 and positive numbers. All positive numbers?
All positive numbers less than 30.
All positive numbers less than 30 or including 30? Including 30. So we can write it as a compound inequality. 0 is less than or equal to x, and x is less than or equal to 30. Stop and think though also, would there be any other restrictions when you think of that part of the number line from 0 through 30? And these are pens. Whole numbers. Whole numbers, yeah. So we have to write where x is a whole number. Then you don't have to list every whole number. 0, 1, 2, 3, all the way up to 30. You can just say where x is a whole number. Not going to sell parts of pens. Okay, so now we know it's not going to go past the x-axis. So at this point, we've narrowed it down to it's either a ray or a line segment. Let's do the range. What would the range be for this?
0 is less than or equal to y, which is less than or equal to 20.
So again, apparently we can't have a negative number of notebooks. We can't go past 20 notebooks. Okay, any other things we need to include here? Where y is a whole number, because again, they're not going to sell you parts of a notebook. Okay, so what do we have then? What kind of a line do we have? A line segment, okay? So you're only going to draw a line segment between the two intercepts and show, and then because we've already stated that x has to be a whole number, we know that not every point on that line segment would count, but only the whole number combinations would. Okay, now let's do part B, where it says to describe what these intercepts mean with this situation. So let's start with the x-intercept. The x-intercept represents, oops, I'm still working with my line tool. Okay, how about a pen? The x-intercept, and we do no abbreviating in sentences, and we're writing a sentence right now, by the way. The x-intercept represents what? What is it telling us? What is that 30 telling us? But also keep in mind that we also want to relate it to the fact that there is a y value along with that x-intercept, okay? So Dylan, what do you think?
How many pens are bought?
Okay, how many pens you bought when what? we know it's $60, so how many pens you bought when, Connor?
You buy 20 notebooks.
No, you can't buy 30 pens and 20 notebooks at the same time, can you really? 30 times 3 for notebooks, that'd be $90 right there. Or no, 30 times 2, I mean for the pens, that'd be $60, and then if you're gonna buy another 20 notebooks at $3 a piece, there's another $60. Ooh, we're way over budget. Trinity? Yeah, so it's the number of pens you can buy when you don't buy any notebooks. Represents the number of pens bought when no notebooks are purchased or bought, however you want to say it. But you need to relate kind of to the fact that our Y value is 0. There are no notebooks being purchased. Here's what I often see for people's descriptions for the intercepts, and I'm going to have to mark it wrong, and so are you when you're correcting your own work. The x-intercept does not represent the number of pens. What represents the number of pens? This is not a trick question. The x-intercept represents the number of pens bought when no notebooks are purchased. If you state it like this, the x-intercept represents the number of pens, period, end of sentence. What are you really giving me? You're not giving me what the x-intercept is representing. You're giving me what? Just what the x value represents. Any x in the situation. You're telling me what any x in the situation represents. I, we, they want to know specifically what does that 1 point on the graph represent, okay? Now see if you can describe the y-intercept. What's the y-intercept representing? The y-intercept represents lines for me. The y-intercept represents. Okay, don't give me another chance here. Do it completely.
Y-intercept is the number of notebooks bought when no pens were bought.
Okay, the number of notebooks purchased or bought. When no pens are purchased or bought, whichever way you want to say it. So, in other words, you can either spend all your money on pens and get 30 of them, or you can spend all your money on notebooks and get 20 of them, or there's some combinations in between where you can get some of each. Questions? Again, we would not say the y-intercept represents the number of notebooks. No, that's what y represents, not the y-intercept. There's a difference. Okay, let's go back and do one additional example then. This one's not in the book, so I wrote it here what the situation is. Trish can run the 200-meter dash in 25 seconds. The function f of t equals 200 minus 8t gives the distance remaining to run after t seconds. Graph this function using the intercepts. Okay, well this time there's not an x or a y in our equation. So what's our x-axis going to be called in this situation? T, and t is representing what? The time in seconds, so we would say time, and then we would say it's being measured in seconds. Well, there isn't a y. We're just going to practice using, so that we get used to this, function notation. That's the f of t axis, the y-axis. And what's the y representing, the f of t representing in this situation? Distance remaining, right? Distance left. So you can use either word, distance remaining or distance left. I think I'm going to use left just because I'm going to run out of room for the big word remaining. And what's it measured in? Meters, little m. Distance left measured in meters. Okay, I've already picked the scale for us, so go ahead, let's get our axes numbered out. You do not have to number every grid line like I started. You can start skipping, okay? Oopsie, I think I'm doing mine wrong. I'm just going by tens. So again, don't label in the spaces between grid lines off to the side of an actual grid line. That's like a tick mark on a number line, okay? So these are two number lines meeting at the origin. Okay, well, you know, this function looks like this. Is that standard form? No. How could we get it in standard form? Add AT to both sides, okay? So get the t's over with the f of t's. So we have f of t, also known as our y value, plus 8t. That does not make them like terms. No, they are not like terms. F of t is not the same as 8t. And now we have it in standard form. And now we can find the t-intercept. So we're going to put, where are we going to put our 0 in? For f of t. So we just put it in, it replaces the whole f of t. And what's our y-intercept, or x-intercept, also known as our t-intercept? What is it? 25. So ordered pair. So ordered pair, 25, 0. Okay? So we can go to your graph and, oh, the 25 is going to be between a couple of grid lines. Place it correctly. And then let's go about finding the f of t intercept. So we got to be able to, transfer our thinking that the independent variable isn't always x. The dependent variable can be talked about as function notation. So we're going to put in for f of t, that's the one we're looking for this time. So we're going to put 0 in for our t value. Do not have to work very hard at all. Our y-intercept, also known as our f of t-intercept, is what? What's its ordered pair name? 0, 200. Okay, so we'll go put that one on our graph. And then before we move on, we're going to decide what would the domain be, what would the range be. What do you think the domain would be in this situation? Can we talk about negative time?
No.
No. Are we gonna talk about time going on forever in the positive direction? No, it stops at what? 25, so we're going to write ourselves a compound inequality, but we're gonna use t in there instead of x, because t is our independent variable this time. How about the range? Can we have negative distance? Negative meters? No. Is it gonna go on in the positive direction forever? No, it stops at 200, so we are going to say 0 is less than or equal to f of t is less than or equal to 200. Well, since they're both restricted there to those regions, would that be a line segment, grade? Line segment. You always have to ask yourself that question because they can be one of any of those three. So draw yourself a line segment connecting those 2 points. You'll have a graph. Well, let's talk about should there be any other restrictions for the domain and range. Can time be measured in parts of seconds? Absolutely. So no restriction to whole numbers there, right? Can distance be measured in parts of meters? Yes, so no restriction to whole numbers there. So that's our domain and range. Okay, let's start talking about what each of those intercepts represents then. So the t-intercept, no abbreviating here like I did up above. The t-intercept represents what? Okay, is it representing her speed? Time, so it's representing how long it takes her to run the 200 meter dash, yeah. Represents the time it takes, not the speed, because the speed is actually going to be the slope, but the time it takes. Is her name Trish?
Yeah.
Okay. To run the 200 meter dash. Again, we don't do any abbreviating in sentences. We write it out. The t-intercept represents the time it takes Trish to run the 200 meter dash. How long does it take her? 25 seconds. I wasn't that fast. Okay. Let's talk about the f of t-intercept. I was fast though, I want you to know, not that fast. Okay. The f of t-intercept represents what? Okay, basically then the length of the race. Yeah, it really represents the length of the race because the time is 0 at that point, so she hasn't even started running it, has she? So it really represents the length of the race, the distance she has to run, however you want to say that. So again, it is not the distance, it is the length of the race. There's a difference. Y represents the distance that she has left to run in meters. The y-intercept represents how far does she have to run. How long is this race altogether? Okay, so questions. Okay, you get out loosely to show your work on, and there are 4 of those 8 problems that you have for homework for which you have to graph. And we're going to talk about what you need to provide on these graphs. There is, I have them handed out when we're ready to talk about, okay?